All right. Good morning, guys. Welcome to Cisco Live, Berlin 2017. My name is Carly. No. I'm clearly not Carly. I know you're all disappointed. And for the disappointed of many, Carly decided to get married. And so she could not come, not because she got married this weekend, but she had a commitment. So because of that, I'm basically Carly's replacement, which means I'm using slides and not whiteboard, because as we discussed before, nobody can compete with Carly's whiteboarding skills. So I don't want to, even try. So I'm a principal engineer. I'm in the same team with Carly, and part of the Insieme business unit, which is the business unit that produces the Nexus 9K, as you guys know. And so today, I know there was a list of topics to talk about, but I picked two, which are ACI multi-site and encryption deployment option, because are the two new things that are going to come in calendar year 17 on the Nexus 9K. And I put reference to sessions that we have at Cisco Live. I don't know if you guys have do you guys have access to the breakout session at Cisco Live or not? Okay. There are sessions anyway that you can actually watch online if you don't have access to the room, that covers microsegmentation, that covers tetration, which are things that have been already out there and documented and presented. So this is pretty much new stuff that, again, is not in secret, but is stuff that will come in calendar year 17. When we usually talk about how to interconnect ACI networks, right? I don't know if you have seen this slide, but we basically have, this is a topic that usually is called DCI, Data Center Interconnect, right? In ACI, we have two family of solutions when it comes to interconnecting ACI networks. What we call single fabric type of solutions and multi-fabric type of solution. And the first solution that has been on the market for like 2-3 years is what we call stretch fabric. And stretch fabric is essentially an ACI fabric. The only difference with a traditional leaf spine two-tier topology is that not all the leaf are connected to all the spines, right? So customers deploy stretch fabric because they have two data centers. They don't have full bandwidth or all the links between these two data center sites to interconnect all the leaf to all the spines. And so they create this topology where some leaf that are called transit leaf are connected to the local spine and to the remote spine, creating a partial mesh type of connectivity. But for all sake and purposes, the stretch fabric, it's an ACI fabric, right? It's basically what we call a single pod, because all the control plane or the fabric control plane of ACI, ISIS and PBGP, COOP, all the protocols that have, they run inside ACI, they run across the entire stretch fabric, right? So it's a single.
So the whole two data center fabric is a single ISIS?
It's a single ISIS domain, it's a single COOP domain, it's a single MPBGP domain. It's a single pod, right? So we usually define it a pod like an availability zone from a networking point of view, right? Which is one of the problems with that approach, because two data centers being the same ISIS domain is something that creates some concern. Because of that, we work on the evolution of the stretch fabric, which is what we call multi-pod. ACI multi-pod. So ACI multi-pod, it's still a single fabric. Why is it a single fabric? Because I still have a single epic cluster that manages all the pods. But now I don't have a single pod, I have multiple pods, which means each of these pods is actually running its own instance of protocols, right? ISIS and PBGP COOP. They are completely isolated in pod 1 versus pod 2 versus pod 3. So from a networking perspective, I actually have independent failure domains, right? I have an issue in ISIS in pod 1. That issue is not propagated to pod 2 or 3 because it's a different ISIS instance. And these pods are all managed by the same epic controller cluster.
So it's still a single failure domain from the management plane.
It's a single failure domain. I wouldn't call it a failure domain. It's a single change domain, meaning if you make a change, the epic cluster is one, and that change propagates to all the pods.
Single instance of fat fingers brings down the whole thing.
It brings down, well, two things, right? At the tenant level, it's true. You go and delete a tenant, that tenant is gone on all the pods. At the infrastructure level, you can actually provide some fate domain isolation, meaning I can create what we call configuration zones, where each pod is a different configuration zones. I make an infrastructure change. I change a VPC policy, right? And that VPC is used across all the pods. I can say that change apply only to pod 1. If I have a problem, affects only pod 1, and pod 2, 3, 4 are OK.
It is one configuration domain for the tenants, but different configuration domains for the infrastructure.
It can be different configuration domain at the infrastructure level. So you know, it's true. You delete a tenant, that tenant is gone, but the other tenant continue to live happy.
How many pods are supported?
We support today 6. We're going to support 12 by the summer, okay, summertime. And we support, so it scales also more than a single pod. So in a single fabric, in a single pod, we can support 200 leaf, right, maximum. Here we support 300 across all the pods, and we will go up to 400, that will be the maximum, right? So.
And you're using MPBGP with EVPN, I see in the middle?
In the middle, because essentially being a single fabric, we need all the spine, all the database in the spine to have a common view where the endpoints are located. Okay?
Which means that you can deploy this in one data center or more data centers. It doesn't matter how you deploy.
Correct. And actually there are 2 use cases, right? The original that was multipod was created for single data center location, different rooms, different halls, right? To chop it up. In reality, I would say in the last year and a half I worked on this, 85% of the customer deploy these across data center, physical data center in a metro area. Because you raise a concern, which is the single change domain, but at the same time it's also a single operational domain management, right? So it's much easier troubleshooting, all the functionality that you have in ACI, you have it across all the pods that are managed by the single customer, right? But because of this concern of the change domain, we have a second set of solutions, which is what we call the multiple fabrics. Now, what we can do today, February 20th, whatever it is what we call multi-fabric, where essentially you have independent ACI fabric interconnected with a traditional layer 2, layer 3 network, DCI technology, right? I have customer running these in production with OTV, for example, in between the sites, and OTV is used to extend layer 2 and layer 3 between the fabric. Is it a solution we want to go for? Yes.
If you're using OTV, is the handoff between ACI and OTV VLAN front?
It's VLAN based. It's a VLAN handoff. But that's why this is not the solution we want to do when you interconnect to ACI fabric. When this is relevant is, this is a legacy data center, VPC based, whatever it is, Juniper data center. This is a new ACI fabric, and you want to interconnect them to do a migration to the fabric.
That's the reference architecture that you've had.
That's what we have today. That's the option we have today. But what we're working on, which is what I'm going to talk about today, is the evolution of that, which is what we call multi-site, right? So now ACI multi-site, if you look at the picture, it looks quite similar to multi-pod. There is a significant difference that each box is a site instead of a pod, which means exactly. Each site is a fabric, okay, which is managed by its own Epic controller cluster. Now, this site could be a multi-pod fabric. This fabric could be a multi-pod, right? So you could have multi-pod fabric here connected to a multi-pod fabric here, a la multi-site, okay?
So in Amazon Web Services terms, each pod would be an availability zone, and each site would be a
region. That is exactly correct. You nailed it, right? So that's exactly, actually, I don't have a slide, but I have a slide in my breakout where I talk exactly in the terms, right? A pod is an availability zone. A region is a site, a fabric, essentially. And so what multi-site gives you, right, is from a data plane, you still have VXLAN site to site, right? So the network in the middle doesn't need to do any special layer 2, layer 3 functionality. It's just routing, right? All the communication happen site to site using a VXLAN encapsulation, which is good in the sense that now I have, not only I have continuity in the data plane, but I also have the capability of carrying policy information in the packet, right? So an endpoint is an EPG in site 1. I can carry that information with which EPG I am when the traffic gets to site 2, right? Which I couldn't do here, right? This solution, the moment you leave the fabric, you lose visibility, you lose a policy, you have disconnected policy domains, okay? Here, we provide an end-to-end policy domain. We provide an end-to-end operational model because we introduce another component to the solution which is called the Multisite Controller, and I covered that in a few minutes. Multisite Controller will basically talk to the different epic. It could be used for 2 main reasons. One is just management, and I can see all my sites and what the health score is in the different site. Or I can use it as a centralized platform where I can jump on the different epic. That's the no-brainer use, but what I can do with the Multisite Controller as well is defining model of application network profile, and then push it to the different site at the pace that I want, right? So if I make a change to a contract, I can make the change, push the change to site 1, and see what happens without affecting site 2, site 3, site 4. So now I have a complete change domain isolation, right, between the different sites, between the different fabrics. That's why there are different regions.
So the multi-site controller is really an orchestration layer on top
of the epics, which uses the REST API on the different epic too. Exactly, correct, right? So, disclaimer, right? This stuff that I'm going to talk about, as I said, is Q3 calendar year 17, so it will come in 5-6 months. It's not secret, has been execute committed, so it's going to happen. But there may be a little change, or they may happen 2 months after the dates I tell you today, so don't shoot the messenger, right? So these things happen, but to the best of my knowledge, all this stuff will happen in Q3 in the summer, right? In Europe, in the summer we go vacation. In America, they work, right? And so Q3, usually July, August is when like last year, Multipod was released at the end of July, right?
I think in America, we released this in 2015, didn't we?
Yes. So, more detail about multi-site, since it's the new. By the way, if you're interested in multipod, there is a session that I'm going to present on Thursday where I go for 2 hours, talk about the detail of multipod, right? Reality is, what I expect is that majority of customers will deploy the 2 solutions together, right? Multipod as a way of deploying a single region, in a region, right? Different data center in the metro area, and multi-site really to interconnect data centers that are more remotely located, okay? So, Ivan, to your point, right? Region A, region B, a region is essentially a site, okay? And we have these separate fabrics that are basically with a multi-site controller on top, an orchestration level, which has web and REST API access, obviously, that will communicate to the different epic to determine the status of the site in terms of health score, et cetera, and also push application network profile, push policies, create essentially a sample of application that needs to be then deployed across the sites. Okay? So that's high-level view of how multi-site will be. It looks a lot like multipod in the sense that we also have an MPBGP EVPN control plane between the sites to exchange information about the endpoint connected to the different sites. The main difference is in multipod, since it's a single fabric, every time an endpoint is connected, we discover it in pod 1 and we send the information to all the other pods because everybody needs to know where the endpoints are located. Here, we can exchange only the endpoint that really need to communicate across sites. So it's more selective, right?
You're using BGP community filters and filter on route targets.
There is under the hood is networking, right? So it's absolutely, right? But it's all done transparently without the need to configure any of this stuff, right? So, but if you need to troubleshoot it, that's what you will go and see and find, okay? So main use cases, and these are main, doesn't mean are the only one, right? 3, there are customers that says, if I have different regions, there is no way that I'm going to extend layer 2 between my different regions. I want only layer 3 connectivity between my sites, right? So multi-site will be used for this type of configuration, where, as I said, a site is a region or a fabric, could be multipod, so I could have an active data center in the metro area done at the site level with multipod, and then use multi-site just for layer 3 connectivity to a remote location, for example. So case 1, I have several customers that told me I only want layer 3 between my data centers, don't go away with layer 2 extension, I don't want it. But then they say, but then I want to do disaster recovery. And when I do disaster recovery, I don't want to readdress my application. I want to move the application to the disaster recovery site and maintain the same IP. So that's a case of IP mobility, which doesn't mean necessarily layer 2 extension or flooding. So the key is to allow the capability of recovering an application in a new site without having to extend in the flooding domain.
Can you take existing tenant configuration in one APIC controller and redeploy that on the fly on the other APIC controller to recreate the environment that's now?
Absolutely. And that will be used, for example, if you already have 2 ACI, you could already have 2 ACI fabric, and you put the multi-site controller, you suck up the configuration from one site, or you have 1 ACI fabric. You deploy a new greenfield ACI fabric, and now you suck up the configuration from site 1, and you deploy part of the configuration to site 2, right? Absolutely. That will be the role of the multi-site controller.
Yeah,
right?
Because that's the smart way of doing disaster recovery.
Absolutely. Absolutely.
How long is the failover time? So one site dies, how long will it take to become this active?
So that depends on how you recover your application. I mean, it's not really networking. So from a networking perspective,
I would only like to know the networking part. I know.
so from the networking part, there are two challenges, right? So if you have the same subnet deployed at two sites without flooding domain in between, you have two challenges. One is what happens if you recover an application here in this subnet and it wants to talk, you have a workload in this subnet, wants to talk to a workload in the same subnet in the other site. How do you take care of ARP, for example? And we will take care of that because through the MPBGP VPN exchange, we know where the endpoints are located. So the assumption here is that if you do a recovery, or a move, a migration of a VM, is a cold migration, right? So that VM will restart, will ARP, and we will discover it, right? It's not a live migration.
The problem you have with that is that you still have the stale ARP entries in the other VMs in that same subnet, so you will have to wait for the ARP.
But that will be taken care. That use case will be taken care, right?
So
it's somehow.
Treat those ARPs out when you get the host route.
We will give you, what did you say, my friend? This is something that I cannot talk about right now. We will give you detail in Vegas. Probably there will be a tech field day in Vegas where we'll...
There's one way to do it.
At the bar. But that's the point, right? So basically, we will be able to provide this is something that Lisp provides today, right? This capability of doing, it does provide it. You may not like it, but that's something. The other point is, if the IP was here and now it becomes connected here, how do I steer my traffic to the right data center, right? And that's where we can do integration, what we call, internally it's called Golf, Project Golf, where basically the ACI fabrics connect to this WAN-edge device using also VXLAN EVPN, and basically exchange host route information. Then you can do host route injection, or you can do Lisp integration. You can do a way to basically ensure that your traffic will be taken to the right site. Because you don't have the luxury of coming to site 1 and use a layer 2 path to site B, because we don't have the layer 2 path in this specific use case.
But okay, we have two challenges, the external connectivity and then the internal connectivity. How long will it take until the internal networks are available on the...
So usually, for disaster recovery, we are not talking about sub-second, right? Convergence, right? If you need a sub-second convergence, then there is the use case 3, where basically it's an active data center, and you have layer 2 extension and flooding in between, okay? Disaster recovery, usually you have your, whatever it is long you can wait, but we're talking about minutes of recovery, right? Usually. But I will give you numbers once we are closer to the release that we can actually test it, right? But, it's a disaster recovery use case. Usually we're not talking sub-second or sub-5-second convergence.
Dominic, it's in seconds or minutes, but it doesn't matter because the storage is not ready anyway.
Correct. Yeah, but for me also would be interesting, do you synchronize the control plane all the time and it's just a failover, or there needs...
When you say control plane, you mean the endpoint? The endpoint, every time there is a change, right? So if an endpoint moves inside a site, you don't need to send any update because it's...
I mean the ACI controllers, yeah? Right. The synchronization, how is that working?
Synchronization of?
Of the two, you have the two separated
Epic clusters,
yes. Epic clusters. How do you synchronize these constantly? With the management between them?
Well, the multi-site controller is where you have your abstraction point that then you can push policies to the different Epic controller. Right? So if you make a change, you make it on the multi-site controller, but you don't want to synchronize the change. That's the whole point, right? You want to keep a degree of freedom in saying, I make a change, I apply it first to that site, and then depending if I'm satisfied with the behavior, I apply also to the other site. Okay? So it's not something, if you synchronize everything at every moment, it's like having a single Epic controller cluster. Yeah. And then you lose your change domain, a scope of change, right? So that's the whole point of the multi-site, give you that degree of freedom of making changes and applying at your pace or whenever you want to do it, at the site you want to do it, okay? So it's not synchronized all the time. It's synchronized when you make the change on the multi-site controller, you push it to the different sites. And I will show you, I have a view of the, a mock-up of the GUI of the multi-site controller that shows exactly that. So the third use case is actually, I call it highly scalable active data center because, and there are few customers I talked to in the last couple of months that they have very massive data centers, right? They're talking about 1,000 top-of-rack switches. And they're like, how can we deploy ACI with 1,000 top-of-rack switches? The problem is, as I told you, in a fabric, we can support 200 today. If the fabric is multi-pod, we can do 300, but not 1,000, right? And so the idea would be, even if it's in the same data center, creating multi-site to basically be able to scale up the number of leaf or top of rack that connect to the fabric. And now, this could be, again, at the point, though, since they are in the same data center location, this customer wants to keep the mobility domain needs to be across the entire data center, so across the sites. And that's where we will be able also to do layer 2 extension and flooding, right? Like we do a multipod. That's more a use case. To me, active data center with flooding is more a use case for multipod than for multi-site. But if we didn't do this, there will be customers that are like, oh, we need to do flooding.
I want to do this, and I don't know why I would use it, and it will crash, but yes, I need this now.
So I prefer to say, yes, we can do it, but you shouldn't, right? Than say, no, you shouldn't, but can you do it? No, I cannot. Yeah, no, we can do it, but probably a better use of multi-site is use case 1 or use case 2.
So the third one is really interesting if you have humongous data center,
Right.
and you hit the scalability limits of the control plane.
Correct.
And so you split the control plane in multiple pieces so that you can scale, but obviously you need the mobility domain across the.
Exactly. And there are, I mean, I didn't make it up. I had like 2-3 discussions in the last month.
I'm just wondering, because these people still have to orchestrate things on the VM level, what they do with their vCenters.
Well, you know, even with multipod, actually, interesting enough, even if we stretched everything, even vCenter, they deploy different vCenters, managing their own cluster, and then they do vCenter 6 migration across vCenter, across VDS, right? But I'm with you, right? You deploy this, you create this isolation, and then you stretch a cluster, it's pointless, okay? It's pretty much pointless. But we will be able to do it, which doesn't mean they should do it, but they can do it, okay? We give you the rope, or we give them the rope, to hang themselves, but we'll tell them not to, okay? Let's put it like this. So one main difference and one challenge that we had to overcome with multi-site compared to multipod is the fact that having different epic cluster means you have different namespaces, right? So when you have an EPGA in site 1 that wants to talk to an EPGB in site 2, the resources like a virtual network identifier, multicast group associated to the bridge domain that we use in site 1 are completely independent with the resources that we use in site 2 because they're two different brains. So we need a layer that does a namespace normalization if I want to have an inter-site communication. That layer is at the spine. Okay, so the spine, and that's the reason why this spine, while multipod, you can deploy multipod with any possible spine that we always supported with ACI. For multi-site, we need at least the EX spine, spine hardware, because it needs to perform this namespace normalization function, right? So that I can, the namespace that is valid in site 1 is shielded from site B, but I can allow this communication inter-site to happen. Because it could happen that two different EPG, they actually use the same VNID in the two sites because the VNID is assigned by two different epics, right? So you cannot control, or this could be an already existing ACI fabric that, as we discussed before, I suck up the config and I put it there. I don't know what resources are going to be assigned to that EPGs on the other side, right?
So on the spine switches, you actually have to do VXLAN to VXLAN routing. Correct. And for that, you need the Cisco ASICs because Broadcom ASICs can't do it.
We use and actually the EX is only Cisco ASICs, right? There is no, But even with it's not only that, it's also more than just the routing, because the routing, we could do it also with the Trident 2 plus the Cisco ASICs. Still more than.
Do VXLAN to VXLAN, or can you do VXLAN to VLAN and VLAN to VXLAN?
We can do everything using the two in ACI, okay? Because we use also it's a combination of the Trident 2 plus the Cisco ASIC. But here, we're talking about hardware, which is all Cisco ASICs in it. 5 minutes, okay. So, but that's an important point, because for customers that today, they think to deploy ACI today, it's good to start with the spine, which is actually EX at least, because that will put them, with the right hardware to then do multi-site when it comes in Q3. Okay? So the message is don't start with the generation 1 spine if you have a new ACI deployment, because then you will have to upgrade to EX or newer hardware.
By the way, how do you match tenant ID here and there in the multi-site controller?
Meaning?
So you have a tenant here.
Yeah.
and then you create a tenant there, and that tenant will get a different tenant ID because the ID is assigned by the local AP controller. How do you measure the two?
Well, that's this translation that happens on the spine, right?
Yeah, that's the data plane. How do you do this in the controller plane?
At the multi-site, that's a good question, and I'm not 100% sure because I haven't played with the multi-site controller yet. But it will be done. Yeah, that's how you answer, right? Honesty is good. No, I'm not 100% sure how it's going to be handled at the multi-site controller. But I'll see you in Vegas, and I'll give you a demo, right? While Carly does the whiteboarding, I'll give you a demo, and I'll show you how that is done. Okay. So since I have 5 minutes, I'm going to skip some of this detail. This is essentially, the key point is we have a network that interconnects my site. This network only needs to provide layer 3 capability, right? Because as I said, all the encapsulation is site to site. It's VXLAN site to site, okay? And we use a protocol, obviously, between the sites and the network in the middle to exchange the VTEP reachability information, what we call the underlay reachability information, because I need to then establish tunnels, VXLAN tunnel VTEP to VTEP across the sites. Okay? So I'm not going to cover this in detail because you will get this information later, right? But if you are interested, you will have the slides that will cover this. For the sake of time, one point is the EPIC and the multi-site controller, they are complementary, right? Multi-site controller is not another EPIC. Will never do all the functionality that the EPIC does. Like, for example, the day 0, the fabric discovery and bring up will be done independently at the different sites. The multi-site controller, as I said, will do these two things, or being able to manage the whole environment from a single point. And I'm going to show you, right? So that's a mock-up of the GUI, right? It may change, but you see basically all the sites that you have deployed from a single location, and you can then drill down and see the health score of each specific fabric, right? Because you connect to the EPIC and you get all the information, health score information from each EPIC. And it gives you, all the score for all the sites that are managed by this multi-site controller. That's use case number 1, no-brainer. But as I said, what is more important is that from the multi-site controller, you will be able to deploy a tenant, you will be able to deploy an application network profile with EPGs, bridge domains, decide this bridge domain is going to be stretched, is not going to be stretched. So all this functionality, all this configuration is going to be done in one place and then pushed, like we show here, maybe. Yeah, and then it can be pushed to a subset of sites, to all the sites at the, with the granular control that I want to have with this different change domain or scope of change. Okay? So this is, again, mock-up GUI. It may be a little bit different, but you get at least the gist of how it is.